ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಿಮಗೆಲ್ಲರಿಗೂ ಶ್ರೀ ಕಾಮಾಕ್ಷಿ ಟ್ಯುಟೋರಿಯಲ್ಗೆ ಸ್ವಾಗತ. ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಒಳಗೆ ನಾವು SSLC 2025 ಎಕ್ಸಾಮ್ಗೆ ಫಿಸಿಕ್ಸ್ ನಲ್ಲಿ ಬರ್ತಕ್ಕಂತಹ 4 ಮಾರ್ಕ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲವನ್ನ ನೋಡೋಣಂತ್ರಿ. ಈಗ ಆಲ್ರೆಡಿ ಕನ್ನಡ ಮೀಡಿಯಂ ಮಕ್ಕಳಿಗೆ ವಿಡಿಯೋಸ್ ಅನ್ನ ಸೆಂಡ್ ಮಾಡೇನ್ರಿ. ಇದು ಇಂಗ್ಲಿಷ್ ಮೀಡಿಯಂ ಮಕ್ಕಳಿಗೆ ಅನುಕೂಲ ಆಗ್ಲಿ ಅನ್ನೋ ದೃಷ್ಟಿಯಿಂದ ಈ ವಿಡಿಯೋ ಮಾಡೇನ್ರಿ. ನನ್ನ ಕ್ಲಾಸ್ ಲೈಕ್ ಆತಂದ್ರ ನಿಮ್ಗೆ ಲೈಕ್ ಮಾಡ್ರಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೋರಿ, ಮತ್ತೆ ನಿಮ್ ಫ್ರೆಂಡ್ಸ್ ಎಲ್ಲಾರ್ಗು ಶೇರ್ ಮಾಡ್ರಿ. ಇವತ್ತಿನ 4 ಮಾರ್ಕ್ಸ್ ಫಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ is explain Faraday's experiment related to the electromagnetic induction. This one is the most important experiment. Faraday's made an important breakthrough by discovering how a moving magnet can be used to generate electric current. First procedure is take a coil of wire having a large number of turns. Connect the ends of a coil to a galvanometer. Take a strong bar magnet and move its north pole towards the one end of the coil. There is a momentary deflection in the needle of the galvanometer. This indicates the presence of current in the coil. When the motion of magnet stops, the deflection becomes zero. Withdraw the north pole away from the coil. The needle of the galvanometer is deflected towards the left, showing the current is now set up in the opposite direction to the first. Keeping the north pole stationary near the coil, and when the coil is moved towards the north pole, we see the galvanometer needle deflects towards the right. Similarly, the needle moves towards the left when the coil is moved away. When the coil is kept stationary with respect to magnet, the deflection drops to zero. It is thus clear that the motion of the magnet with respect to coil produces an induced potential difference which sets up an induced electric current in the circuit. Understand that? ಇದು ಫುಲ್ ಪ್ರೊಸೀಜರ್ ನೋಡ್ರಿ. ನಾ ಯಾವ ತರ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಹೇಳೀನಿ, ಇದು ಯಾವ ತರ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಬರ್ಸಿಂದ ಇದ ಟೈಮ್ ನೀವು ಎಕ್ಸಾಮಿಗೆ ಬರ್ದ್ರಿ ಅಂದ್ರ ಔಟ್ ಮಾರ್ಕ್ಸ್ ತಗೋಬಹುದ್ರಿ. ಇದನ್ನ ನೀವು ಜಾಸ್ತಿ ಕಮ್ಮಿ ಮಾಡಿ ನಿಮ್ಮ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ತಗೊಂಡು ಬರೀಬಹುದು. ಅದನ್ನ ಏನ್ ಹೇಳಿಕೊಟ್ಟಿಲ್ಲ ಇದೇ ಟೈಪ್ ನೀವು ಬರ್ದ್ರ ನಿಮ್ಗೆ ಔಟ್ ಸೈನ್ಸ್ ಒಳಗ್ ಮ್ಯಾಥ್ಸ್ ಬರ್ತೈತ್ರಿ, ಸೈನ್ಸ್ ಒಳಗ್ ಮಾರ್ಕ್ಸ್ ಬರ್ತಾವ್ರಿ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ಹೌ ಡಸ್ ದ ಐ ಅಕೊಮೋಡೇಟ್ ಟು ಸಿ ಫಾರ್ ಅಂಡ್ ನಿಯರ್ ಆಬ್ಜೆಕ್ಟ್? Why do star twinkles? Explain. The first question is how does eye accommodate see far and near objects? The eye lens is composed of fibrous jelly-like materials. Its curvature can be modified to some extent by ciliary muscles. The change in curvature of the eye lens can thus change its focal length. When the muscles are relaxed, the lens becomes thin. Thus, focal length increases. This enables us to see distant object clearly. Understand that? The question nimga. The next here is, when you are looking at object closer to eyes, the ciliary muscles contract. This increases the curvature of the eye lens. The eye lens becomes thicker. Consequently, the focal length of the eye lens decreases. This enables us to see nearby object clearly. Next, idralaga innond question ಏನು ಕೇಳಿದ್ರಿ? First, how does the eye accommodate to see far and near object? ಇದು ಹೇಳ್ಕೊಟ್ಟಿನಿ. ಇದ್ರೊಳಗೆ ಇನ್ನೊಂದು ಕ್ವಶನ್ ಕೇಳಾರ, why do stars twinkle? Explain. ಹೌದಾ? Why do stars twinkle? Explain. The twinkling of star is due to Atmospheric refraction of the sunlight. Refraction, atmospheric reflection ಲಿಂದ ನಮ್ಗೆ ಏನಾಕೈತಿ, refraction ಲಿಂದ ಏನಾಕೈತಿ, twinkling of the star. The straight line on entering the earth's atmosphere undergoes refraction continuously before it reaches the earth. The atmospheric refraction occurs in the medium of gradually changing refractive index. Understand ಆಯ್ತ್ರಿ ಇದು? The next question. ಇಲ್ಲ, ಇದ್ರೊಳಗೆ ಇದೇನ್ ಕೇಳಿದ್ರೊಳಗ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೇಳಾರ, ಹೌದಾ? ವೈ ಡು ಸ್ಟಾರ್ಸ್ ಟ್ವಿಂಕಲ್ ಅಂಡ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನೋಡ್ರಿ. ಸಿನ್ಸ್ ದ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಬೆಂಡ್ಸ್ straight line towards the normal, the apparent position of the stars is slightly different from its actual position. This apparent position is not stationary but keeps the changing slightly. Since the stars are very distant, they approximate point-sized sources of light. As the path of the rays of light coming from the stars goes on varying slightly, the apparent position of the stars fluctuates and the amount of the starlight entering the eye flickers. The star sometimes appears brighter and at some other time fainter, which is a twinkling effect. Understand ಆಯ್ತಲ್ರಿ ಇದು ನಿಮ್ಗ? The next question. Explain the experiment of drawing magnetic field lines around the bar magnet with the help of compass needle. Mention two properties of magnetic fields. The first one is explain the experiment of drawing magnetic field lines around a bar magnet with the help of compass needle. Drawing magnetic field lines around a bar magnet using a compass needle. Place a bar magnet on a white paper and mark the boundary of the target. Place the compass needle near the north pole of the magnet. The south pole of the compass needle directs towards the north pole of the magnet. Mark it with a point. Move the needle to a new position such that its south pole occupies the position previously occupied by its north pole. Mark it with a point. In this way, proceed the step by step till you reach the south pole of the magnet. Join the points marked on the paper by a small curve. This curve represents the field line. Next, ಇದರೊಳಗೆ ಇನ್ನೊಂದು question. Mention the two properties of magnetic field lines. The properties of magnetic field lines are: field lines emerges from north pole of a magnet and merge at the south pole at the south pole. Inside the magnet, the direction of the field lines is from its south pole to north pole. ನೋಡ್ರಿ, ಫೀಲ್ಡ್ ಒಳಗೆ ಏನಾಕೈತಿ, ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಇದೊಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂತ ತಗೊಂಡ್ರ, ಇದು ನಾರ್ತ್, ಇದು ಸೌತ್, ಹೌದಾ? ದ ಫೀಲ್ಡ್ ಲೈನ್ ಎಮರ್ಜಸ್ ಫ್ರಮ್ ನಾರ್ತ್ ಪೋಲ್ ಟು ಸೌತ್ ಪೋಲ್. ನಾರ್ತ್ ಪೋಲ್ ಟು ಸೌತ್ ಪೋಲ್. ನೋಡ್ರಿ, ಇಲ್ಲಿ ನಾರ್ತ್ ಪೋಲ್ ಟು ಸೌತ್ ಪೋಲ್ ಆದ್ರ ಇಲ್ಲಿ ಇನ್ಸೈಡ್ ದ ಮ್ಯಾಗ್ನೆಟ್ ಒಳಗೆ ಏನಾಗೈತಿ, ಸೌತ್ ಪೋಲ್ ಟು ನಾರ್ತ್ ಪೋಲ್ ಮೂವ್ ಆಗ್ತಾವ. ಸೌತ್ ಮತ್ತು ನಾರ್ತ್ ಮೂವ್ ಇಲ್ಲಿ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತಲ್ರಿ ಇದು? ನೆಕ್ಸ್ಟ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಕ್ಲೋಸ್ಡ್ ಕರ್ವ್ಸ್. ನೋಡ್ರಿ, ಇವು ಕ್ಲೋಸ್ಡ್ ಏನಿರ್ತಾವ, ಕರ್ವ್ಸ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಸ್ಟ್ರಾಂಗರ್ ವೇರ್ ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ crowded. Now, two field lines are found to cross each other. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತಲ್ರಿ? ಇದ್ರೊಳಗೆ ಎನಿ ಟೂ ಬರ್ದ್ರೆ ನಿಮ್ಗ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. Explain an experiment to show that a current carrying conductor experiences the force in a magnetic field. The second is how is a simple electric motor converted into a commercial motor? First is explain the experiment to show that current carrying conductor experiences the force in a magnetic field. First is take a small aluminum rod and suspended it horizontally using connecting wires. Place a strong horseshoe magnet in such a way that rod lies between the two poles with the magnetic field directed upwards. Connect the aluminum rod in a series with the battery, key and a rheostat. Next, now pass the current through aluminum rod in one particular direction. The rod displaces towards one side. Reverse the direction of the current flowing through the rod displaces towards the opposite side. Hence, a current carrying conductor experiences a force perpendicular to its length in a magnetic field. Understand ಆಯ್ತಲ್ರಿ ಇದನ್ನ? ಇದರೊಳಗ ಸೆಕೆಂಡ್ ಏನ್ ಕೇಳಿದ್ರು, how is a simple electric motor converted into commercial motor? By replacing permanent magnet with a electromagnetic. By increasing the number of turns of the conducting wire in the current carrying, by using a soft iron core on which the coil is wounded. Any two ನೀವು ಬರೆದ್ರೆ ಸಾಕ್ರಿ, ಇದಕ್ಕೆ 1 marks. Next question. State the right hand thumb rule. Write any two properties of magnetic field lines. What is a solenoid? How can this be converted into an electromagnet? Right hand thumb rule is when you are holding a current carrying conductor such that the thumb points towards the direction of the current, then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. Understand ಆಯ್ತಲ್ರಿ? ಇದ್ರೊಳಗೆ ಮತ್ತೇನ್ ಕೇಳಾರ, ರೈಟ್ ಎನಿ ಟೂ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಹೌದಾ? ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ emerges from north pole and merge at a south pole, closed curves, never intersect each other, having magnitude and direction. Understand ಆಯ್ತಲ್ರಿ? This is also most important question. Next, what is solenoid? A coil of many circular turns of a insulated copper wire wrapped closely in the shape of cylinder is called solenoid. How can this be converted into an electromagnet? Current carrying solenoid can be used to magnetize a piece of magnetic material like soft iron and placed inside the coil. Understand ಆಯ್ತಲ್ರಿ ಅದು ಕ್ವಶನ್? ಮತ್ತೆ ಇದ್ರೊಳಗೆ ಏನಾರ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ ಬಟ್ ವಾಟ್ ಇಸ್ solenoid? How can be it converted into an electromagnet? Next question. State two laws of reflection of light. Write any two differences between concave mirror and convex mirror. State two laws of reflection of light. The angle of incident is equal to the angle of reflection. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. These are the two laws of reflection of light. Right? Any two differences between concave mirror and the convex mirror is here is the differences. Concave mirror, this is a convex mirror. Concave mirror, reflecting surface is curved. Reflecting surface is curved outside. This is a concave mirror, means reflective surface is curved inwards. In convex mirror, reflecting surface is curved outwards. Understand the first difference? The second difference is size of the image may be small, big and equal to that of the object. In convex mirror, size of the image is always small and direct. In concave mirror, virtual and real images are formed. In convex mirror, always virtual image is formed. In concave mirror, it is used in the torches, searchlights, vehicles, headlights having shaving mirror. These are the uses of a concave mirror. Next, convex mirror. It is used in rear view side mirror of the vehicle. Understand the students? The next question. Write any four uses of concave mirror. Second question is in this question, second is an object is placed at a distance of 50 centimeter on the principal axis in front of a concave lens with a focal length of 10 meter. Find the image distance. The uses of concave mirror are used in torches, searchlights, uses in vehicles, headlights, used as a shaving mirror. The dentist used to test or examine teeth of patients. The fourth is used in solar furnace. Here, an object is placed at distance of 15 centimeter, principal axis in front of a concave lens with a focal length is 10 centimeter. Find the image distance. Given is f is equal to minus 10 centimeter, u is equal to minus 15 centimeter. The formula is 1 by f is equal to 1 by v minus 1 by u. Minus 1 divided by f is at minus 10. Minus 1 divided by 10 is equal to 1 by v plus, here is a minus, minus into minus is a plus 1 divided by 15. Next is a 1 by v is equal to minus 1 divided by 10 minus 1 divided by 15. Taken 10 and 30, 10 and 15 LCM should be 30. Therefore, 1 by v is equal to 30. 10 3s are 10, 3s are 30, 3 1s are 3 minus 3 minus 15 2s are 30, 2 1s are 2. That means 2 1s are minus 3 minus 2 minus 3 minus 2 divided by 30. That means 1 by v is equal to minus minus ಬಂದ್ರೆ add ಮಾಡಿ minus ಚಿಹ್ನೆನೇ ಇಡಬೇಕಂದ್ರೆ 3 plus 2 is a 5 minus 5 divided by 30. 5 ones are 5 6 that means 1 by v is equal to minus 1 by 6. V is equal to minus 6. It's a reciprocal. Understand students? Therefore, the image distance is minus 6 meter. Next question. State the Joule's law of heating. Name any two devices that works on the application of this law. Why are alloy like nichrome used in electric heating devices? The first question is a state Joule's law. The heat produced in the resistor is directly proportional to the square of the current of for a given resistance, and heat is directly proportional to the resistance for the given current and is also directly proportional to the time for which current flows through the resistance. Next, the devices that work on this law are electric toaster, electric oven, electric kettle, electric bulb, electric fuse. Right? Any two. Next, ಇನ್ನೊಂದು question ಏನು ಕೇಳಿದ್ರು? Why are the alloys like nichrome used in electric heating devices? Resistivity of alloys are higher than the metal of alloy. Do not oxide or burn readily at high temperature. Alloy having a high melting point. Understand the question? The next question is, state Ohm's law. In domestic electric circuit, electrical appliances are not connected in series. Why? Second question is, write the factors on which resistance of conductor depends. The V is the potential difference V across the ends of the given metallic wire is in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. In series circuit, the current is constant through the electric circuit. Due to this, all electrical appliances are not possible to work at the same value. In a series connection, when the one component fails, the circuit is broken. The next question, write the factors which resistance of a conductor depends. The factor which resistance of a conductor depends on length of a conductor, area of cross section of a conductor, nature of the material, and the temperature. Understand actually? The next question is, what are the advantages of connecting electrical devices in parallel in an electric circuit instead of connecting them in series? Next, second question, how are the ammeter and voltmeter in electric circuit? What are their function? Advantages of connecting electrical devices in parallel. The parallel circuit divides the circuit through the electrical gadgets. When one component fails, the circuit does not fail. The total resistivity in a parallel circuit decreases so that electrical edges get connect as per their resistance required. How are the ammeter and the voltmeter in an electric circuit? What are their functions? In an electrical circuit, ammeter is connected in series. In an electrical circuit, voltmeter is connected in parallel. Ammeter measures the rate of electric current in a circuit. Voltmeter measures potential difference across the ends of the conductor. Understand that? That is the next question. Observe the given diagram. Explain the experiment related to this diagram. What conclusion can be drawn from this experiment? Ends of the copper coil AB. The ends of the copper coil AB connected to the galvanometer, the north pole of the bar magnet. NS is moved inside the coil. Induced current is produced in the coil, and hence the needle of the galvanometer shows momentary reflection in one direction. ನೋಡ್ರಿ ಇದ್ರದ ಮತ್ತೊಂದ್ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನೀವು ಬರೀರಿ. ನಿಮ್ಗೆ ಏನ್ರ ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ರಿ, ಇದ್ರ ಮೇಲೆ ಮತ್ತೆ ನಾ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಒಳಗ ನಾನು 4 ಮಾರ್ಕ್ಸ್ ಇಂದ ಕಂಪ್ಲೀಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲಾನು ಮಾಡ್ತೇನ್ರಿ. ನನ್ನ ಕ್ಲಾಸ್ ನಿಮ್ಗೆ ಲೈಕ್ ಆತಂದ್ರ ಒಂದ್ ಲೈಕ್ ಮಾಡ್ರಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊರಿ, ಮತ್ತೆ ನಿಮ್ ಫ್ರೆಂಡ್ಸ್ ಎಲ್ಲಾರ್ಗು ಶೇರ್ ಮಾಡ್ರಿ. ಥ್ಯಾಂಕ್ ಯು.